Okay, hi future people. I am filming an ad hoc lesson on crop planning. Here we go. So, I finished the crop plan last night at like midnight. That's how I chose to spend my evening. And it was actually really fun, and I couldn't stop thinking about it. So I had to take like medicine to go to sleep, which is not unusual. This workshop's off to a great start. But it helped me think through the factors that I keep in mind while crop planning, help me identify them. And normally I do it without thinking about teaching it to other people, so I don't really articulate all the things that I think about. So this was a cool exercise. So I guess I'll start with concrete. Like, our field is about 2/3 of an acre. It's about 160 by 160 feet. And so that allows a certain amount of isolation distance for crops that would hybridize if you had them too close to each other. So I guess what I'll say first is here, like, the factors I came up with. I'll give you all the headings now, and then I'll talk about each of them. One is crop rotation, and that's something that all farmers and gardeners likely practice. There's certainly some philosophies that don't believe in crop rotation, but most people who I talk to do. And so I'll talk more about that, and that's basically moving. You don't have the same species in the same spot 2 years in a row, or sometimes even 3 or 4 or 5 years in a row. Like, people will keep track of many years of crop rotations to avoid replication. I'll talk about that more. The other big thing, as I was just talking about with isolation distance, is preventing accidental hybridization or unwanted hybridization between two different varieties of the same species. So we'll talk about that, and we'll do a little activity for isolation distance too. The other kind of more minor but still important considerations are how long is the crop in the field. Many of these crops are all season long. Many of them are out by June or July. Some of them are crops we can do more than one succession of. And so taking advantage of that available field space. Other considerations are how tall is the plant, how much space does it take up, does it block the sun out of other plants, etc. Another is, can it live in partial sun? Can it live in the shadow of one of those tall plants, or can it not? Which plants are going to sprawl 20 feet in each direction? And how to plan around that when your rows are 3 feet wide and the pathways are 3 feet wide. Succession planting, using the space that frees up, or making sure we have multiple crops of the same variety for different purposes, like cut flowers or selling the produce, which we don't do. What's resistant to deer, rabbit, and groundhogs? What's resistant to certain insect pests? What's going to keep away rodents or invite rodents? How do we use pollinator plants to improve seed production and also act as a buffer between seed crops? And on our farm, it's fun to sometimes have, this is the Southern Italian section, this is the Andean section. So thinking of how people move through the space and what they experience. Here's the cut flower section, So those are the different things I came up with that impact how we lay out our field. I think the one we'll spend the most time on is isolation distance, because that's most specific to seed production, but all of them played a role in our crop planning. And also, even as much as I'm recording this, feel free to interrupt at any time. It's more important that we have a common understanding than to have some kind of product, you know what I mean? So just ask any questions. For crop rotation, it's really helpful. Most farmers that I know and gardeners are familiar with the crop families that they're working with, at least, even if people don't know the genus and species of their plants, because for the most part, crop families have similarities in terms of pests, in terms of what they like use in the soil in terms of nutrition, what they like in terms of sun and water. So you can generalize for a lot of things based on its family, and you can have a sense of how it might grow, or nutrient needs and so on based on the family. So before I became a seed farmer and a seed keeper, that was like good enough for me. I wasn't interested in learning the Latin or scientific names of plants because it didn't really serve me, and I felt like I had enough information based on the crop family. I do think crop family is really important if crop rotation is important to you, which it is for most farmers, like I said. My partner doesn't rotate as much. Shumei is the name of the Japanese farming system, spiritually rooted farming system that he learned a lot from, and they don't actually believe in crop rotation for different reasons. But I'm gonna put that aside because I don't use that method, but I want to acknowledge it. Shumei, I think it's Shumei.
Is there any system to Shumei then, if it's not based on rotation?
Well, I can't speak really well to it because I haven't studied it the way he has, but a lot of the systems are spiritual, and a lot of them are no-till, natural farming methods. So having to do with not disturbing the soil.
Which you also don't do.
Yeah, we don't till. We're inspired a lot by Korean natural farming methods. And farms that I've worked with that's learned from those practitioners. So yeah, we don't till either. So there's definitely systems to it.
And what is the reason behind not tilling versus tilling?
We don't till because it is extremely disturbing to the ecosystem of the soil and the soil structure in general. And if you imagine the life of the soil with macroorganisms like worms and other bugs moving up and down, especially worms, creating these channels, that help move water and air through the soil and nutrients because the worms are pooping the whole time, And so there's these intricate systems and pathways moving through the soil. And then the microorganisms that inhabit those highly structured soil spaces, both on the level of like the conglomerations. I don't know what you actually call it with soil. Something like that. It's like conglomerate. It's like there are these like structures, these little, if you see little, like this even. This is probably mostly worm poop. But like how it's held together, that's held by all these different substances and living organisms. And there's nutrients in there. This helps like with water regulation, moisture control in general. Like if the soil's intact, it's doing a pretty good job usually of managing itself, right? And there's a whole world of creatures in there living off of that. And when you till the soil, you're destroying that structure, you're cutting those up. A lot of times tilling, especially in relationship to precipitation, can like create a hard pan that's impenetrable by precipitation, flooding, the root zone doesn't get water, and the microorganisms, the bacteria, the fungi, they are just like, think about the mycelium structures that go between plants and across soil and really far sometimes, and they deliver nutrients to plant roots, and they deliver information between plants of the same species sometimes. And so you're just like chopping it all up. So it's as someone who grew up on more conventional practices, it's tempting to make like a nice cake out of the soil, to have like this fluffy bed that's like you can put your whole arm into, but it's like you've decimated the life and the ecosystems in that soil.
It's a principal factor of desertification in the West right now.
Yeah, it's where the Dust Bowl came from. Yeah.
Even I learned about the aerobic and anaerobic. The ones that don't breathe. When you till or turn you kill the ones that were breathing, you put them down, and you bring the other ones up. So a lot of things.
Yeah,
die.
there's a delicate balance,
Yeah.
even between like communities of bacteria and communities of fungus. So part of no-till, some of the no-till systems, is also thinking about, is your soil fungally dominant or bacterially dominant? And like at the farm, Tobacco Road Farm, where I worked a couple seasons in Connecticut, this is now 10 years ago and like 15 years ago or 17 years ago, they will bury a box of rice. They follow the Korean natural farming system that they learned from people in Hawaii. That they bury this like cooked rice in the soil, in the like leaf litter of the forest where soils are more fungally dominant. They're like perennial ecosystems versus the field, which is like annual ecosystems. And so these perennial ecosystems of the forest, they need fungal growth to like break down dead trees and like break down the leaf litter and things like that. And so they kind of inoculate their rice with this these organisms from the forest and introduce them to their field. And this is something we haven't done really. I tried it a little bit at our last farm. I really want to get back to it when we have a permanent location and can be more settled. But introducing that rice that's inoculated with bacteria and fungus, but a lot of fungal organisms, into like a compost system that increases their population, and then you can introduce them, and it's more complicated. There's several steps. It smells like a cookie baking because like it starts with like bran or something and molasses, and like you feed them all the things that make them increase. And then you introduce them into a compost system, and then that can go into your field either with foliar spray onto the plant's leaves or through compost application, so it's like side dressing or whatever into the soil. So yeah, so no-till is recognizing that world, that invisible world that is also visible in how the soil structure looks and how the water acts. And it's been beautiful for us. And it just means adopting new practices that don't involve tractors or rototillers, but instead like using a lot of hand tools and solarizing with plastic, so it's not like a perfect, entirely peaceful solution because we're using plastic, but to solarize instead of destroying the whole soil, just the surface level, killing off the weed bank and the crop residue and turning it back into not turning it, but like leaving it to feed the next crop. So, yeah.
There's a Netflix film called Kiss the Ground that introduced that to me, the no-till, and it's really informative, really interesting. Anyone?
Yeah, I want to see that. I've never seen that. Cool. Yeah, so we're a low-till farm because we moved last year and we had to till. We got permission to use the land on like April 5th. And we had crops that should have been in already. And so we had to prepare this entirely grassy field for crops. And so we tilled, and if we were there for years to come, that would be the only time we ever tilled. Last year, we're not going to till this year. We wouldn't till ever again, probably. But it's when you're breaking new ground, sometimes it's going to have to be tilled one time. Or it was actually a series of 3 times over a month. Just so that you can turn the perennial grass over and make space for annual crops. So, what's that?
Birds are really loud.
I know, the birds are really loud.
And it's like prime migration.
Yeah, they were. I heard them last night too.
Welcome back.
So crop rotation. Yeah, so for example, like tomatoes, peppers, eggplants, ground cherries, uillas, uchubas, tomatillos. You all know the name of that family? Yeah, Solanaceae. So it's like a Latinized name. Beans, peas, black-eyed peas, astragalus. You know the name of that family?
Beans?
Yeah.
Fabaceae?
Oh, that is one of the names of that family. Yeah, I know them as Legumiaceae or something like that. But yeah, Fabaceae. Yeah, that's probably the real name.
The nitrogen source.
Yeah,
Legumiaceae.
Yeah.
Fabaceae, yeah. Which, you can hear the same word like in fava bean. Yeah, so knowing those crop families is just, it's this human system that we've created to categorize the plants that we encounter. And like I said, it helps us understand some things about them as a category. But it is human created and it's ever changing. And so what I did when making this map, and I'll show it to you guys in a little bit, is to make sure I didn't put 2 solanums or Solanaceae plants. They all have a lot of names for their family. I call them solanums, the tomato family, so that they didn't go in the same spot as a solanum. Last year I just kept track on the side of my map of what was in that row. I didn't worry about the bed ends too much, like our little plots at the end of each bed. It's just too many. It's already hard enough to plant a crop. But I did for the major crop, like rows. I put what was there last year so that I didn't repeat the same family twice. For some of them, like squashes, like the squash family, I even tried to move it to a whole other part of the field. Not even just be like a row away or 2 rows away, but actually another part of the field, because of different like fungal diseases, lots of pests. A lot of the squash family plants, like cucumbers and summer squash, are more susceptible to like downy mildew and things like that. And then like the worms that get in there and bore into the vines. And so I don't know if moving them across the field is going to help that much, but I particularly wanted to move the Cucurbitaceae plants. So that's the basics of crop rotation. Pests, diseases, nutrient uptake. Corn is a heavy feeder. Solanums are heavy feeders. They take a lot of nitrogen out of the soil. So usually I like to put heavy feeders where there was a bean family plant the year before, because it fixes that nitrogen, or vice versa. So like thinking about that kind of stuff, really visualizing. I realized like as I'm planning, I'm like visualizing that previous crop, problems, great things about it, like fixing nitrogen, like what's it adding or taking from the system.
That's so fun.
Yeah, and so that helps, like, gives a little boost to your plants if you do it right, or like you can avoid a problem if you do it right. So that's kind of the basics of that. I'm not going to go too deep into crop rotation, but that's like pretty much the first thing to think about for us. The second major thing and the big learning curve for a lot of people when producing seed crops is isolation distance. And so since we're dealing with the sexual reproduction of plants, and plants reproduce sexually through through the wind, or through insects, or through self-pollination, depending on what the mode of reproduction, like what the vehicle is for reproduction, it changes like how far they have to be from each other to prevent unwanted cross-pollination. And so by knowing if the plant is a selfer, like legumes or tomatoes, or an outcrosser, like squash or corn, can tell you a lot about how much space it's going to need to prevent those varieties crossing in an unwanted way. And the reason we're trying to prevent that, even though the plants would prefer to cross that way, is we're offering culturally important varieties that people want to look and taste a certain way. Otherwise, there's people out there who are intentionally crossing plants as much as they can because the plants get vigor. There's a hybrid vigor. That's why people love hybrid plants, because coming from 2 different parent lines, there's a vigor that comes from that introduction of like genetics that makes them stronger and grow better in a lot of cases. So what we're doing with preserving culturally important heirlooms is really like a genetic bottleneck, because we're trying to keep them like frozen in time so that they taste and look how we want them to. And so but that's like what we're doing. Like people came here from all corners of the world and want to have that flavor of home, or people who are still here, who are originally here and are like trying to survive through colonization, want the flavor of home. And so the work that we're doing by nature is a genetic bottleneck situation. There's ways that we fight against that, and that's a whole other discussion, but how to ensure genetic diversity despite trying to keep things pretty stagnant in terms of what they taste and look like. There's a lot of strategies for that. But again, that's like another discussion I'm excited to talk about with you all. But on the front end, we want to keep like the purple hull pink eye pea with a purple hull and a pink eye, you know? And we want to keep like the Sea Island red pea like small and cute and little and red, you know, and they would cross with each other and make a baby and change. So knowing what, not just like whether they're self-pollinating or outcrossers, that's helpful. But then looking species by species at people's like recommendations for specific number of feet or meters is really what I do. And before you can do that, you have to know what's considered the same species as what else. And that's where you look again at like these categories imposed by humans, further down than family, but down to genus and species. And so it's a matter of like understanding binomial nomenclature is what it's called. And so until I started dealing with seeds, I thought it was an unnecessary categorization. But now, because we're caring for these beloved seeds, I feel like I have to know. And so binomial nomenclature, I have a little activity we can do to understand how it works. And so normally when I'm in a workshop setting, I ask people, I like pick a crop family, and I usually do squash and I usually do beans, and ask people like, what's your favorite variety within this family? So I'm wondering if you can each pick your favorite squash plant in the squash family. Butternut. Kabocha. Can you guys write your... Oops. We just use whole papers. You can use that whole paper. You can use that whole paper. No pressure. It doesn't have to be your favorite. It can be...
Yeah, the favorite
This
part
one's
is
kind of
what
bad.
feels like.
This marker's not great, sorry.
So just write it down.
Yeah, we'll say it out loud. Make room too, because we have to write the genus and species. If I can tell you so far.
Here you go.
Yeah. What ones are you all picking?
I don't know enough squashes names.
If you were at the store, what squash would you choose for your family?
But I'm limited in the squash. I know the butternut.
Zucchini?
Huh? Oh, okay, that's a squash?
Yeah,
Oh,
zucchini,
okay.
yeah.
No, cucumber, yeah.
Or, okay, cucumber's fine.
Thank you.
What do you pick?
Delicata.
Delicata.
Fancy.
So far, so good.
It goes really well with like a red curry.
Summer ones?
Or Seminole.
Oh, Seminole. Okay, great. All right, so I'm going to tell you your species, okay? You know yours? Anyone know theirs already?
Didn't you say Curbit?
Cucurbita maxima for you.
Yeah.
Cucurbita maxima. You gotta maybe write it big. We're gonna have to see each other's papers.
Is it with a K?
C-U-R. The three of you are... No, not you, sorry. What was yours again?
Delicata.
Yeah, the four of you are Cucurbita. C-U-R-C-U-R-B-I-T. A. No, there's no first R. Cucurbita. Spelling doesn't matter. You're Maxima, you're Moschata, you're Cucumis sativus, and you're Cucurbita pepo, P-E-P-O.
What is that you just told me? What is it?
Yes, that's cucumber. Cucumis sativus.
Sativus.
Yep.
And that is the species or the family?
So Cucumis or Cucurbita for them is the genus. So the first, in the binomial nomenclature, the first name is the genus.
Okay.
And the second name is the species.
Species, thank you.
So now, if we understand that humans decided that each species is distinct because it cannot procreate with a different species, then, and I tell you that the squash family requires half a mile of isolation between varieties of the same species, what do we need to do in this scenario? Where do people need to move? Yeah, how far?
Like half a mile.
I'm gonna run to the park there.
That might even not be far enough.
So a full mile?
A half a mile.
Half a mile.
Yeah.
That's a good distance.
Does anyone else need to move?
Don't we all need to move? 'Cause
Well,
we
no,
all
the
are
three of us are technically different species, right?
So it doesn't matter if it's the same genus. It's just the same.
Well, that's a
different
good
species.
question.
Right.
Squash is a complicated world.
Yeah.
But in general, actually, I just asked this question to the small seed companies listserv I'm on, and almost everybody said, don't worry about it if you're this different species within the Cucurbita genus. They're like, we've never seen crossing, or I've seen crossing once in 20 years, or, you know, there's something called an interspecific cross, where you have the same genus. There's even an intergeneric cross occasionally, across two different genera.
Genus.
But with Cucurbita, if you hand pollinate, you could make a cross between your two species, and also between, I think, your two species, and I don't know if you can between these two species. So I'm just learning about the world of Cucurbita. But for the most part, if you're a different species, you don't have to worry about it. So with the ones you selected, we could grow all of them in one place, except we'd have to pick one from the two of yours.
Well, we're the butternut and...
So same species cannot be planted in.
Well, within a certain distance. Yeah, and for squash, it's a far distance. It's a half a mile. Because they're insect pollinated, they're purely outcrossers.